Alright, for number 1, you need to find the slope of this line. So you need to remember your koi bucks. What was the slope of this line? You guys can set up. Undefined. Is that not what you said? Is that what you said? Okay. Okay. For number 2, is the following set of ordered pairs a function? Venus says yes. Do we agree? Yes. Yes. We have non-repeating x values. They all go to the same y value, but that's okay. And then for number 3, we need to evaluate this function. So put in -5 for x. This would give us 2 times 25, or 50, minus 3, so 47 is our final answer. That was really sloppy, sorry. Questions on 1, 2, or 3? Moving on to the back, we need the domain and the range of this. Remember, we need numbers that are least to greatest. For our domain, what was that? You guys can say them out loud. -4. 3 was the next one.
-3.
Is there one at -3? -3 would be the next one. It does go to 3, but because these are ordered pairs, we have to list them all out. So -2. Next one. -1. You guys can just say them out loud. The next one. 1. And then
3.
So when we have lists of numbers or random order pairs, we have to list out all of the numbers. We can't just put from the first to the last, because if that were the case, that means there'd be some connecting line to say it's everything in between. And it's not. Okay. For our range, least to greatest, what were those values? -4. 2. There's 2 at 2, but we're not going to put repeating numbers. 3 and 4. Right. And then for number 5, you could have done this one of 2 ways. You could have solved this and then found the solution, or looked at it, use your rules, and determine how many solutions it was. How many solutions was this? 1. And you can look at this, see that these don't have the same coefficient or constant, so infinitely many and none can't be the solution. Anyone need to see this solved just to see what the answer would have been? Not that it asked for that, it just asked how many solutions it had. Right. Everyone should have new notes on your desk. Today we're going to be talking about solving systems by elimination. This is the third way to solve systems of equations. Third and final way, I should say. So make sure everyone's paying attention. I don't remember what all of these are, so I'm just going to pull this down. So at the top, this says add/subtract or multiply and then add or subtract/subtract to eliminate a variable. That's how we use the elimination method. The steps 1, make sure your equations are lined up. That means x with x, y with y, your constants together. Step 2, add or subtract equations to eliminate the variable with common coefficients, so the number in front of x or y. Step 3, solve the equation for the remaining variable. Step 4, substitute your answer into into either original equation and solve for the other variable. And then if there aren't common coefficients, multiply one or both equations by a number to make them common. And some of you started working on the Khan Academy Delta Mass already, so you have an idea as to how to do this. But this wording may not make sense now, but it will when we do some examples. Okay, on the next page, does anyone still need this before I move on? These boxes are not that big, so I'm going to try to write big but small enough to fit in the box. So if you can't see it, just let me know and I can either move it or write bigger. Right. So first, these, I can look at these and say that these are lined up. My y's are in the same place, my x's are in the same place, my constants are in the same place. Even though this one has a coefficient of 1, so it doesn't kind of look like they line up, but they still are. And my equals is in the same place. Once I know all of those things are in place, then I can move on to adding or subtracting to eliminate one of the variables first. What does it mean to eliminate? X out, get rid of. One of the variables is going to go away. And that's our goal. It doesn't matter which one. You could get rid of x or eliminate x or y. You just have to make that choice. Which one do you want to eliminate first? In this case, the easiest one to eliminate would be our y's. Because, I'm sorry, and I skipped a step. We also need to look for which one has the same or a common coefficient. So in this case, these both have a coefficient of 1. So those will be what I'm going to eliminate. Once you figure out which one has the common coefficient and we can eliminate those, we're going to look at, we're trying to get it to become 0. So we need to either add these two together or subtract them. Which one would give us 0? Adding or subtracting? Subtract. So what I'm going to do is bring a minus out to like the side. And I'm subtracting this entire equation from the first one. So think about it like when you are solving equations, you're doing something similar, but now we're doing the entire equation all together. So then I'm going to do this step by step. Y minus y will give us 0. 3x minus x would give us, double check that, 2x. And then 4 minus a negative 2 would give us 6. Not negative, it would be a positive 6. So when you do this, one of your variables should go away. That way you can solve for whatever variable is left. So here we could solve for x by subtracting both sides by 6. And then this next part is just like the substitution method. Once you have one of the x or y, put it back into one of your equations and find your other. So So for this one, these both have a y equals, so it doesn't matter which one you choose, pick one. I'm going to choose this bottom one, y equals -3 minus 2. And then once you have your x and your y, put those together in an order pair. Before we move on to the next one, do we have any questions on that one? Amina? Yes, one of the x or y has to become 0. Right. For number 2, which variables have the same coefficient? X. So we can eliminate those. Would we add or subtract to eliminate them, sorry?
Add.
Subtract. X plus x equals what? Would that eliminate them? So subtract. So x minus x would be 0, yes. 4y minus -y. Not 3, it is positive.
Why?
5. And then 13 minus 3 would just be 10. I meant to say this earlier. These weren't in slope-intercept form, and that's okay. As long as they line up, it's fine. So here, divide both sides by 5, so that y equals 2. Put this back into either one of the equations, it doesn't matter which one. I'm going to choose the second one. So I can add 2 to both sides. So my order pair would be 2, 5.
Yeah.
Yeah, 5, 2. I said it backwards. One, 2, 3, 4, 5, 7. Questions on example 2? For number 3, which one has common coefficients? The y's, the 2's. And then to eliminate them, we would do what? Minus, subtract. 4x minus -2x is 6x. 2y minus 2y is 0. So once you start to get the hang of this, you don't have to keep putting the 0. Know that you eliminated it to become 0. But you could not put anything for your y's. If it helps you remember where it went, definitely keep doing that. I'm going to not put it. 6 minus 18 would give us -12. That way we can just solve for x and ignore the 0. And then, which equation do we want to put this back into? The first or the second? Okay. It doesn't matter. So this would be positive 4 plus 2y equals 18. Subtract 4 on both sides. Get 14. And divide both sides by 2. -2, 7 would be our answer there. questions on number 3? So far, we've had coefficients that were exactly the same. They were both the positive. We haven't had any negatives yet. In number 4, it could also work if they have the same number, but maybe one's positive and one's negative. This may differ a bit from what Conradin said, but both methods work. Conradin's method and so here, I see that these both have a 4, one's positive, one's negative. We can still use those and eliminate our x's. If we're eliminating our x's, would we add these two or subtract these two to get 0? Add. 4 plus a negative would really be 4 minus, and they would become 0. A rule you can kind of, if this, you don't know when to subtract, when to add, something that could help is if you have 2 positives or if you have 2 negatives, you're going to subtract. If you have a positive and a negative, you're going to add. So there's only one case where you add, but there's 2 where you subtract. Right, so 4x plus a negative 4x would give us 0. 9 plus 7 would give us 16. 5 plus 11 would also give us 16. So when we solve for y, we would get 1. And then did we want to put that back in the first or the second? Which one did you say? First. Okay. 4x plus 9 times 1 equals 5. So 4x plus 9 equals 5, and we can start solving for x. So negative 1. Negative 1, 1. When we do this next one, I think this is the one we're going to end up with some fractions. Sometimes that happens. On this page, I think there's at least 2 examples with fractions, and this is one of them. I'm going to do this below, so I have more space. Negative x equals 3y plus 11. And 2x minus 3y equals 1. Thank you. Yeah, I will. Okay. First, our x's and our y's, yes. It's not negative. Okay. The 2 or the 3? Okay. First, the x's and the y's and the constant are lined up, but the equal sign isn't. So we need to either rearrange this so that the y is on this side, or rearrange this so the y is on this side. Doesn't matter which one, they'll work out the same. Which one do we want to rearrange, the first or the second? What were you going to say? You're going to say different. If we'll do the first because I heard that first, and then we'll solve the second first. And if you want to do the other one, you can do that one too. Do that one instead. I'm going to rewrite this first one so that it's down here. You may need to use the back of this sheet if you need more space, or an additional sheet of paper. Okay. Here, in the way I solve this, our y values or our y coefficients are the same, so we can get rid of those. Supposed to say equal sign? Say that one more time.
It says 3y equals 2. There's 2 equal signs.
Oh. Is this
2 plus.
3 plus? I was like, thank you. Okay. Are we adding or subtracting? Subtract. 2x minus negative x would give us
3x.
3x. 3y minus 3y would be 0. 10 minus 11 would be negative 1. So when we divide this, we're going to end up with a fraction. So we can take this fraction, put it back into one of the others. I said you put this back into the first. So negative 1/3 equals 3y plus 11. This would become 1/3. And then we could solve for y.
We do fraction
Often, no. I think there's only one more example in this. I don't believe that happens very often in Khan Academy. It may happen, I'm not sure. But it shouldn't happen in Delta Math, I believe. Someone put in your calculator 1/3 minus 11.
Negative 32.
Negative 32 over 3. Did we all get that?
Yeah.
And then, because this is already a fraction, instead of dividing by 3, I'm going to multiply this by 1/3. So negative 32 over 9. You guys can double check that. That equals negative 32.
Yeah, that's nice too.
Put over 9. So yeah, that would not have been a nice point to find if you were doing it on your own. There is one more that I'm going to have you guys do that is a fraction, that you'll end up with fraction answers, but the process will be the same. Just be careful when you put the fractions in. Questions on number 5? We're going to do 2 more, and then I'm going to let you do some on your own. We're going to skip 6 and move to 7. Yes. Actually, we're going to do, yeah, we'll still do 2 more, but I'm going to change the ones we're going to do. We'll do 7 and then we'll do 9. For 7, here we have x's and y's that are both the same. That means you have a choice. You could pick x or y to eliminate. Okay. And we would add or subtract to eliminate. Subtract. When we do this, because we're subtracting and these are the same, and to eliminate these, they would also subtract. What's going to happen is they're both going to eliminate. Because 3 minus 3 is 0. Negative 4 minus a negative 4 is 0. Negative 10 minus negative 13 would be 3. So it is no solution.
And the slopes are the same, so if you
Yes. So the slope, if you change these both to slope intercept form, they would be parallel lines. You'll also see that here they were exactly the same. It's just the n numbers weren't. So that would also tell you it's going to be no solution. We're going to do two more because this might be. Okay. We're going to skip to 9 now. Do we have common coefficients? No. So this would be a case where we have to make common coefficients before we do anything. Doesn't matter if you want to do this for x or for y, you choose. First, let's do that. Do we want to get rid of x or do we want to get rid of y? X. X, okay. If we're getting rid of x, we need to make these two coefficients the same. That means we need to multiply either one or both of these by something so that they both have the same coefficient. So we can multiply by 2, sure. If we multiply just the top one by 2, then they would have the same coefficient. If we wanted to make them both like 4, we could do that. The higher up you go, the bigger these numbers become, so just be careful with that. So when we do this, we're going to multiply this entire equation by 2, because we can't just multiply one part of it. When we do that, I'm going to write this underneath here. So that new equation would be 2x plus 6y equals 12. Now I can say that our x's have the same coefficient, so we can subtract these two to eliminate them. 2x minus 2x would be 0. Negative 7y minus 6y would be negative 13y. Negative 1 minus 12 would be negative 13. And then we could divide both sides by negative 13. Before we find our x value, does anyone have any questions on how we got to that part?
Could you multiply by negative 2?
You could do that as well. So if we multiply by negative 2, then we would be adding. The numbers you get might be a little different, but you would still end up with 1. Any other questions before we continue? After you find your y value, you now have 3 different choices to put y into. This original one, this one, or the new one that you changed it to. It doesn't matter. They should all work. Woo. Were you going to say something? You have your hand on the phone. Are you okay? Say, what were you saying? The original. Okay, what's your question?
Y plus 7y to the
We're still subtracting. So it's negative 7y minus a negative. Minus of positive. So really you're just subtracting. You're not. Okay, so which original?
The x plus 3y.
So if we put y into this one without the 2, that would be x plus 3 times 1 equals 6. And then we could solve for x by subtracting both sides by 3. order paired would be 1, 3. Nope, 3, 1. I did it again. 1. My bad. Just so I know that you fully understand this process, we'll do one more and then I'll let you guys out. Or 10, do we have common coefficients? No. So we need to eliminate x or y. Which one do we want to get rid of? X. We need to make these both the same number. What is a multiple that these both go into? 15. So that means we would need to change them both. Multiply the top one by 5 and the bottom one by 3. So our new equations would be 15x plus 15y equals 45. And then 15x plus 12y equals 30. Now we have the same coefficient. Now we can eliminate by doing what? Subtracting. 15x minus 15x would be 0. 15y minus a positive 12 would be 3y. 45 minus 30 would be 15. And then we could divide.
So when we get y equals 5, can you put 5 into any of those 4?
Into any of the 4. So now you have 4 different choices to put y into. Don't do more than one, but choose one. Doesn't matter which one. Let's say I go with this first one, and I don't really have space, so I'm going to do this off to the side. So 3 times, I'm sorry, just 3x, plus 3 times 5 equals 9. We have 3x plus 15 equals 9. Subtract 15 on both sides to get negative 6. And then divide both sides by 3. Here.
So when we solve, we'll use the original ones.
You could use the original, you could use the new one, it doesn't matter. I just chose that one because it was the first one I saw. Negative 2, 5 would be our answer then. So we've gone through 8 of these problems. There are 7 left. Go through those 7, work through those 7, and then we'll go through those. I'll check in about 15 minutes. It may not take you that long. It may take you longer. And see where everyone is. If you need my help or have any questions, I'll be around. Check with other people at your table, because they may have a similar question or may have done it a different way than you did. You guys have this in your work? So this is a scanned-in copy of my answer key, so it's a little difficult to read. I'm just going to read out the answers, and if you need to see the words more clearly, I can rework it. Number 6 was 40. 8 was infinitely many solutions. We did 9, we did 10. 11 was no solution. 12 was 1, negative 4. 13 was negative 8, 5. 14 was no solution. And 15 was the other one with fractions. 13 halves or 6.5. and 21 halves, or 11.5. Do you have questions on any of those, or need to see any of those worked out? So for the remainder of class, you guys will have time to work on all of the Khan Academies that are due today or tonight. The 2 graphing ones, the 1 substitution one, and the 1 elimination one. And then the Delta Math, so if you haven't done these already, there's 1 on graphing, 1 on substitution, and then 1 on elimination that is due next class. You guys have the rest of this class to work through those. Let me know if you have questions on any of those or need help.